Hey everyone, so in this video we're going to go into some more identities that we're going to cover, but to start with I just want to remind you of a few things. We first have these even and odd functions, and you were kind of introduced to this in 171, so I'm not going to go into a lot of detail about it, but the biggest things you just need to know is that if we have sine of negative x, that is also equivalent to the negative sine of x, and that also matches up with tan. Tan, you have that negative inside, and then that negative can move to the outside. Those will give you equivalent values if you actually worked through those. The only one that's a little bit different, and kind of like we talked about with cosine with sums and differences, he likes to change up a little bit, is cosine. If we have a negative here, it remains positive. Okay, so definitely that's something that's in your book, but that was introduced in 171, so we're not going to spend a whole lot of time on it. As far as cofunctions, though, we have talked about this already in chapter 6. Okay, we wanted to think about it as complements of each other. We know complementary angles add up to be 90 degrees. All right, so if I had a value of sine of 40 degrees, we know that that would be equivalent to cosine of 90 minus 40, which would be 50 degrees. So those values are equivalent. If I tried to find sine of 40 and cosine of 50, we would get those same values. So we know sine and cosine go together in both directions. It does not matter. Secant and cosecant and tan and cotangent. Those are all cofunctions that go together. Now another way to look at this that's being introduced in this chapter is when we think about these values as in radians. We've talked about converting to radians. So if I have 90 degrees, either you remember from your unit circle, or if not, we can convert very quickly. We know times pi over 180. So I have 90 pi over 180. And if we simplify 90 over 180, we know we get pi over 2. Now that we are okay with working with radians, these cofunction values can be used with radian values. So I can use any forms of these over here. It does not matter which one I use. Sine of x is also equivalent to cosine of pi over 2 minus x. So degrees will work for cofunctions as well as radian values, because we know that 90 degrees is equivalent to pi over 2. Now there's also some other variations of cofunctions. We're not going to use them a whole lot, but they are in your book for you to look at on page 508. They just look a little bit different as far as sums and differences. You want to think about what we talked about with sine. We know sine, if we had plus or minus, they matched up perfectly. And if we used cosine, remember we called him the evil cousin because he would flip for us. So if we were doing a positive version, cosine would be negative. So that's just a little bit different to look at. Okay, so this is really some values that you're going to be given as an example. And what they're doing here is just giving you an actual value to work with. So I know sine of 11 pi over 90 is 0.3746, and cosine of 11 pi over 90 equals 0.9272. So obviously those are values that are not exactly on our unit circle. It's not like square root of 2 over 2 or anything like that. That's going to be nice for us to work with. But they will give you all of these values. And we want to know, what can we do to help us solve using cofunction values? So this part at the bottom right here, and I kind of cheated a little bit and went ahead and wrote this down. This part right here I'm highlighting in yellow, that is not going to be given to you. I just went ahead and did that. But the only thing that I did, y'all, is convert 11 pi over 90 to degrees. And the reason I did that is because if you notice all these examples down here, they went ahead and gave them to us in degrees. So once again, if we have forgot how to do that, 11 pi over 90 to degrees times 180 over pi. The pi's cancel. I'm going to do 11 times 180 over 90, and I know that that gives me 22 degrees. So that's where I got this highlighted pieces in yellow. I just went ahead and converted both of mine to degrees, so it makes it a little bit easier for us to work with. So let's do some of these examples. We just want to make sure we know what matches with what, or what can we use to help find these, okay? So we're going to use cofunctions. Now, for tangent, however, though, think about what we know with tangent. You can kind of think about this with some reciprocal values or some equivalent values, okay? I know tan is considered to be 1 over cotangent, but we're not given cotangent. I know also, however, that we can write tangent as sine over cosine. And since we were both given those values, that would be the easiest thing for us to do. So sine of 22 over cosine of 22 degrees, which I know is 0.3746 over 0.9272. We want to use the values that they give us. 0.3746 divided by 0.9272, and I get round to the fourth decimal place 0.4040. Okay, so we know tangent can be sine over cosine. As far as cotangent, very, very similar. The only difference is we know with cotangent that I can actually just flip those values. I know since they're reciprocals of tangent, I can do cosine of 22 over sine of 22. So the exact same thing, we're just flipping the values that we're solving. And then we'll just divide them once again. So 0.9272 divided by 0.3746, and I get 2.4751. Oh, I'm sorry, I need to round that last one, 2. Okay, so all of these values will work out. As far as cosecant, remember cosecant goes with sine, so I can just do the reciprocal, okay? And I know we're using a lot of words of cofunctions and reciprocals. Please remember, cofunctions and reciprocals are not the same, okay? Reciprocals, we know we have 1 at our top because we're flipping that value. But when we're talking about cofunctions, that's when we're just subtracting. And we're going to notice that when I do this other side here. Cosecant, I can do 1 over sine of 22. So 1 divided by 0.3746. So that's where that reciprocal value comes in. And I get a 2.6695. And then finally, the last one right here, I know secant is a reciprocal. So 1 over cosine, 0.9272. And then once we get these values, y'all, there really shouldn't be anything else for us to do in this question, because this is where our cofunction is going to come in. I have all of these values for 22 degrees. Well, if you notice, the rest of these angles are 68 degrees. The reason for that, because if I do 22 and 68 together, I know that is 90 degrees. So they are complements of each other. So we want to go back and remember with our cofunctions, what matches up? Sine and cosine, secant and cosecant, tangent and cotangent. We're going to use those values to help us solve here. So my next one is sine of 68. Well, I know sine and cosine are cofunctions of each other. So whatever I got for cosine of 22 should be the same answer as sine of 68. And once again, the reason for that, sine of 68 cofunction equals cosine of 90 minus 68, which we know is cosine of 22. And they gave us that. So 0.9272. And that's the value we're going to use. Same thing in this example up here. Cosine we know goes with sine. So automatically 0.3746. Tangent goes with cotangent. So I'm going to slide over to where I had cotangent. So we know that those values are going to match. So 2.4752. Cosecant matches with secant. So I'm going to use that value. Okay, and so on, y'all. These are all cofunction values. You just match up what we know works with each other. Sine and cosine for cofunctions, secant and cosecant, and tangent and cotangent. So the same thing would do for these last two right here. You're just going to follow through and fill those in. Okay? And the last thing we're going to do in this video is double angle. Okay? These are all double angle identities. You'll definitely need to know these. They're very, very important. We have sine double angle 2x equals 2 sine of x times cosine. Cosine of 2x equals cosine. I know these twos are kind of weird right here. Cosine, this is really supposed to be squared. Okay? I don't know why it typed like that. Let me fix that for y'all. This is supposed to be cosine squared of x minus sine squared of x. Okay? So I don't know why these twos didn't stay for y'all, so you can mark this one out. Supposed to be cosine squared of x minus sine squared of x. And then we notice we have two tangent functions. I wrote both of them down here because the book will show you both. MyLabs Plus will show you both. We don't use this one. It makes the work a lot harder for us to do and time consuming. This is the one that I will use more often and I would advise you to use because most of the time we're going to be asked to find sine and cosine first, and then we can just put those on top of each other. Just like we did with reciprocal values, we know tangent is sine over cosine. It'll work out perfectly. Okay? Now, let's do this first example. We're not jumping into double angles yet. I just want to remind you of simplifying with trig values. We've done this already in a previous section, but I haven't given you an example quite like this because it's going to involve double angles. So when we used to simplify in previous videos, we wanted to make sure that we could simplify as much as possible and plug in anything that we could or take out anything that we could and make it as small as possible. We want to get rid of as much trig values as possible. So I notice right now I have parentheses, so I'm going to distribute first. So I have sine squared x minus 2 cosine x sine x, just from multiplying. And then I still have my plus cosine squared x in the back. Now, as soon as you see this value right here, we see that there's a 2 attached right here. Think about doubling. I'm multiplying by 2. So if you notice up here with sine, it says 2 sine cosine x. Technically, that's exactly what we're doing here. It's just written in a different form. But remember, with multiplication, it does not matter what order you multiply something in. So I can go ahead and take this 2 cosine x sine x and make it into sine 2x, which is our double angle. And then now these other pieces right here that I'm going to highlight for y'all. I want to see if y'all remember this. Remember looking when something is squared, we are thinking of Pythagorean identities. Well, sine squared x plus cosine squared x, if you remember, was equivalent to 1 from our Pythagorean identity. So that's exactly what I'm going to do. I'm going to put those together and make them a 1. Now, nothing else can actually happen there for us, so we're going to be able to leave it alone just like that. And in the next video, we're going to go into more detail and do some examples with these double angles.